Okay, so welcome back to this next video in which we are discussing type 1 phosphoinositide 3-Kinase enzymes. Okay, right, so we're in the process of discussing what a phosphoinositide is so that we can discuss what a phosphoinositide 3-Kinase enzyme is. Okay, right, so we've discussed what a lipid molecule is, we've discussed what a phospholipid molecule is, we've discussed what a phosphoglycerolipid is, and we now want to see a specific example of a phosphoglycerolipid, which is the molecule Oops, this pen is starting to go. No, it's fine. Which is the molecule Phosphatidylinositol. Okay, and this is a running theme in the naming of phosphoglycerolipids. Okay, they're all named with this prefix phosphatidyl. Okay, and what this means is I contain phosphatidic acid. It's referring to this entire structure here. Okay, and I've said that all the phosphoglycerolipids contain that structure. Okay, so that portion of the name just tells you that it contains the phosphatidic acid molecule. Then inositol, this is telling you what molecule you have added onto the phosphate group of the phosphatidic acid molecule. Okay, and we're going to have added an inositol molecule. Okay, so now let's study inositol. Okay, so inositol is again an old name for a molecule that would now be called cyclohexane. Okay, a 1, 2, 3, 4, 5, 6, and then hexol. Okay, so yes, it is more of a mouthful, but it's a good name because it tells us exactly what this actually is now. Cyclohexane tells us that we are dealing with a 6-membered carbon ring. Okay, so let's draw this. So I'll draw a little skeletal formula. In fact, I think I'll go over onto the other page. Okay, so I'll transfer the cyclohexane 1, 2, 3, 4, 5, 6 hexol so that we have the name sitting in front of us. Okay, so cyclohexane 1, 2, 3, 4, 5, 6 hexol. So we've got 6 alcohol groups coming off this molecule, and 1 comes off each of the carbons of the cyclohexane ring. And remember, the old name for this, and the more commonly used name, certainly in biology, is inositol. Okay, right, so let's draw a skeletal formula for this. So remember, in skeletal formulae, you don't show carbon atoms. They are implicitly shown by corners. Okay, you also don't show hydrogen atoms coming off carbon atoms. If you have missing bonds coming off carbon atoms, it's implicitly understood that those are 2 hydrogen atoms. Okay, so this is the skeletal formula for a cyclohexane ring. Okay, we've got 6 carbons here, 1, 2, 3, 4, 5, 6. They are joined nicely together in a cycle, and all of the bonds between the carbons in this cycle are single bonds. Okay, now, we also want to have an alcohol group coming off every single one of the carbons of this cyclohexane ring, okay, to create cyclohexane 1, 2, 3, 4, 5, 6 hexol. Okay, so that means we're going to have an alcohol group coming off every single one of these, and it also means we're going to have a hydrogen coming off those. Okay, so each of these 6 carbons here is going to have both an alcohol group coming off it and also a hydrogen coming off it. Okay, now you might think, well, how lovely, how simple, but there's a subtlety here, okay, and this is the subtlety of optical isomerism. Okay, there is not just one optical isomer, I'm afraid, of inositol. There are many different optical isomers of it. Okay, so we're going to have to consider optical isomerism. So, imagine that these 6 carbons of this 6-membered ring here, okay, imagine that those are sitting within the plane of the piece of paper. Now, you can't exactly do that, but you can get very close. So we'll imagine that they are sitting within the within the plane of the piece of paper. Okay, right. Now, off each of these carbons then, we've got 2 bonds. We've got a bond to a hydrogen, and we've got a bond to an alcohol group. Now, one of these bonds is going to come off at an angle like that, okay? And one of these bonds is going to go into the page at an angle like this, okay? So the question is, do you want the hydrogen to come out of the page towards you and the alcohol group to go into the page away from you, or do you want it the other way round? Do you want the alcohol group to come out of the page towards us, or the hydrogen to go in and the hydrogen to go into the page away from us? Okay, so there are actually 9 optical isomers of inositol. Now, we are not going to go through all of them, and the reason we're not going to go through all of them is that only one of them is actually found in any decent amount within cells. Okay, and this is the optical isomer of inositol called myo-inositol. So if you ever hear anyone talking about myo-inositol, you now know that it's just referring to the specific optical isomer of inositol that is found within cells. Okay, now let me show you the actual conformations of the alcohol groups and the hydrogens as far as coming out or going into the page is concerned in myo-inositol. Okay, so we'll start with this carbon here. The alcohol group coming off this carbon here is going to be coming out of the page towards us, okay, like so, and the hydrogen therefore will be going into the page away from us, okay. Then off this next carbon here, it'll be the same. The alcohol group is going to come out of the page towards us, like so, and then the hydrogen will be going into the page away from us. Off this carbon here, the alcohol group will be coming out of the page towards us, like so, and then the hydrogen will be going into the page away from us. So again, it's exactly the same for those 3. Now we're suddenly going to mix it up. The alcohol group off this page is going to be going into the page away from us. Oh, and I should have said, I will denote bonds coming out of the page towards us by this structure where it gets thicker towards the end of the bond. Okay, I will denote bonds going into the page away from us by dashed lines like so. Okay, then off this next carbon up here, we're going to have an alcohol group that comes out of the page towards us, like so. And then finally, off this one up here, it's going to go once again into the page away from us. Okay, so I'm not going to show the hydrogen atoms, because remember we're drawing a skeletal formula, which means I don't have to show the hydrogen atoms. I implicitly show the hydrogen atoms by having carbons which have missing bonds off them. So each one of these carbons has a missing bond, and it's implicitly then understood that that is to a hydrogen atom. Okay, right, so this is the structure then of myo-inositol. Now, if you have an inositol molecule and you want to figure out whether it's a myo-inositol molecule, you have to try and superimpose it on this image. If you can do, then it's a myo-inositol molecule. Okay, also, the carbons of a myo-inositol molecule have a specific numbering system. So this carbon here is known as the first carbon of myo-inositol. This carbon here is known as the second carbon of myo-inositol. This one is the third, this one is the fourth, this one is the fifth, and this one as the sixth. And that's going to become important in a moment. Okay, right. So let's now talk about phosphatidylinositol, which is a phosphatidic acid molecule linked via a phosphoester link to a myo-inositol ring. Now, we don't specifically state phosphatidyl myo-inositol in the name, okay, because whenever a biologist talks about inositol, we assume that everyone understands we're talking about myo-inositol, okay. Unless you talk to a chemist, you're never going to find anyone who's working with a form of inositol that isn't myo-inositol. Okay, right, so let's start by drawing the phosphatidic acid molecule. Okay, so here are the 2 long-chain carboxylic acids. Here's the glycerol molecule. Here is the phosphate group. And now this phosphate group is going to be linked via phosphoester link to the alcohol group that comes off the first carbon of this myo-inositol ring. So it's going to be linked to this alcohol group here. So I will denote the myo-inositol ring as this blue hexagon here. Okay. Here then is the phosphate group, which is in purple here. The glycerol molecule is this vertical line in green, and then we've got our long-chain carboxylic acids in blue. So this is phosphatidylinositol. So finally now, we are ready to discuss what a phosphoinositide actually is. Okay, so a phosphoinositide is a derivative of phosphatidylinositol. So all phosphoinositides come from this molecule, which is why we needed to discuss this molecule before we could discuss more general phosphoinositides. Okay, right. So how do you create a phosphoinositide from phosphatidylinositol? Well, basically, you add further phosphate groups onto the other alcohol groups of this myo-inositol ring. Okay, and again, these will be added on via phosphoester links of the phosphate group onto the alcohol groups that come off these other carbons. So let me give you an example then of a phosphoinositide. And I should stress, you only need to add on one. If you add on more, that's great, you're still a phosphoinositide, but you only need to have one. So basically, a phosphoinositide is a phosphatidylinositol molecule that has at least one phosphate group added onto one of the alcohol groups that comes off the second, the third, the fourth, the fifth, or the sixth carbon of the myo-inositol ring within phosphatidylinositol. Okay, so let's see some examples. So let's stick one phosphate group that will come off the alcohol group that comes off the fourth carbon of a myo-inositol ring within the phosphatidylinositol. Okay, now this will be called phosphatidylinositol. Okay, so we're always going to have that now in our name. Okay, and now we've added on a single phosphate group onto the fourth carbon, so it's going to be called phosphatidylinositol 4-phosphate. Okay, and for short, phosphatidylinositol 4-phosphate is often just abbreviated to PI for phosphatidylinositol, and then they put a 4 there, and then they put a P. Okay, so P and then P is for phosphate, so it's phosphatidylinositol 4-phosphate. Okay, so that's our first example then of a phosphoinositide. Let's now look at another example of a phosphoinositide, and we're specifically looking at the examples which we're going to need in a moment for discussing phosphoinositide 3-Kinase enzymes. Okay, another example of a phosphoinositide, a very famous example, okay, probably the most famous example, is Phosphatidylinositol 4,5-bisphosphate. Okay, and this is going to have a phosphate group coming off both the fourth carbon's alcohol group of the myo-inositol ring and also off the fifth carbon of the myo-inositol ring, like so. Okay, so this is the fifth carbon here. Now, this is why I went to the lengths of discussing the specific optical isomer of inositol that is present within phosphatidylinositol molecules, and moreover just in the cell generally. Because if I just drawn this cartoon, what would you have named this? What would common sense have told you to name this? You'd have named it phosphatidylinositol 3,4-bisphosphate. You'd have said that's the third carbon, that's the fourth carbon. Okay? You have to understand that there is a difference between the fifth carbon and the third carbon of myo-inositol. The fifth carbon sits in between two carbons which have alcohol groups going in opposite directions to the direction that the alcohol group which comes off the fifth carbon is going. Okay, if on the other hand we look at the third carbon, this sits in between two carbons, one of which is going in the opposite, one of which has its alcohol group going in the opposite direction to the alcohol group that comes off the third carbon. But this other carbon will have its alcohol group going in the same direction as yourself. Okay, so the third carbon and the fifth carbon are subtly different. Okay, this is not a symmetrical molecule rotationally. Okay, so bear that in mind. That's why I've stressed this point, so that you can understand that there is a difference between phosphatidylinositol 4,5-bisphosphate and phosphatidylinositol 3,4-bisphosphate. Okay, right. So phosphatidylinositol 4,5-bisphosphate. Now, the strict abbreviation for phosphatidylinositol 4,5-bisphosphate is PI for phosphatidylinositol, and then we put brackets 4,5, and then we put P2. Okay, so this shows us that we've got two phosphate groups coming off the fourth and the fifth carbons of the inositol ring within the phosphatidylinositol. However, this molecule is so famous that you can just abbreviate it to PIP2. Okay, so you don't have to tell me which carbons these phosphate groups come off. If I see this written, okay, if I see phosphatidylinositol with 2 phosphate groups off, with no clarification which carbons they come off, you instantly assume that they come off the 4th and the 5th. If someone was talking about a phosphoinositide where they came off, for instance, the 2nd and the 3rd, they would absolutely stress that fact. They would not just abbreviate it to PIP2. The only one that you can abbreviate to PIP2 is when the phosphate groups come off the 4th and the 5th carbons of that myo-inositol ring, because this is the most famous, basically. So PIP2 or PIP2 is phosphatidylinositol 4,5-bisphosphate. Okay, right, so we're now in a position to discuss the 3 different types of phosphoinositide 3-Kinase enzymes. Okay, right, so let's do this. Phosphoinositide 3-Kinase enzymes. So the clue is in the name. These are enzymes which are going to phosphorylate phosphoinositides on the 3rd carbon of the inositol ring, basically. Okay, so they're going to phosphorylate phosphoinositides. Where are they going to phosphorylate them? Well, it's on this 3rd carbon here. Okay, so they are going to add they're going to add phosphate groups onto the alcohol group that comes off the 3rd carbon of the inositol ring within phosphatidylinositol derivatives, or within these phosphoinositides. Okay, right. So there are 3 different types of phosphoinositide 3-kinase which differ in which substrates they act on, so which phosphoinositides they are actually going to phosphorylate. Okay, so the one that we are going to discuss, and the most important within cells, are the type 1 phosphoinositide 3-kinase enzymes. Okay, now, type 1 phosphoinositide 3-kinase enzymes are going to have as their substrate PI45P2, okay, or PIP2. Okay, so phosphatidylinositol, where we have 2 phosphate groups coming off the myo-inositol ring, and they're going to come off the 4th carbon and the 5th carbon of that myo-inositol ring. Okay, so let's colour in the inositol ring here in blue. Let's colour in the 3 phosphate groups in purple here. Let's colour in the long chain carboxylic acids in orange, and finally the glycerol molecule in green. Now, type 1 phosphoinositide 3-kinase enzymes are going to phosphorylate the 3rd carbon of the inositol ring here, okay, and that will create us this molecule here. So once again, here is our phosphatidic acid molecule. Here's our inositol ring here, and we've now got phosphate groups coming off the 3rd, the 4th, and the 5th carbons of that myo-inositol ring here. Okay, so we've now got 4 phosphate groups on the entire molecule here. Okay, so once again we'll colour this in. So here's the inositol ring in blue, here in green is the glycerol molecule, and here in orange are the long chain carboxylic acids attached to the alcohol groups that come off the 1st and 2nd carbons of the glycerol molecule. Okay, so what then is the name of this molecule? Well, it has still as its foundational structure phosphatidylinositol. Okay, so we'll start with phosphatidylinositol, and now we just need to tell the person what carbons you have phosphorylated. Okay, so it's going to be phosphatidylinositol, and we've got a phosphate group coming off the 3rd, the 4th, and the 5th carbon. So it's phosphatidylinositol 3,4,5, and now we've got 3 phosphate groups, so it's tris phosphate. Okay, so what is the abbreviation then for phosphatidylinositol 3,4,5 trisphosphate? Well, PI is the abbreviation for phosphatidylinositol, and then we'll have brackets 3, 4, 5, and then we've got 3 phosphate groups coming off, so P for phosphate, we've got it 3 times, so P3. Okay, now, once again, this is an extremely famous molecule, okay? So you can get away with abbreviating phosphatidylinositol 3,4,5-trisphosphate down to PIP3. So you don't need to tell me which phosphate groups which carbons the phosphate groups actually come off. Okay, if you don't clarify which which carbon atoms the phosphate groups come off, it is assumed that they come off the 3rd, the 4th, and the 5th. Okay, so if you write this, I will assume you mean this. Okay, so this molecule is often just abbreviated to PIP3 or PIP3. Okay, so type 1 phosphoinositide 3-kinases convert phosphatidylinositol 4,5-bisphosphate molecules into phosphatidylinositol 3,4,5-trisphosphate molecules. Okay, next up, the type 2 phosphoinositide 3-kinase enzymes. Okay, these are a little bit more niche knowledge, okay, and we're not going to focus on them in this video. Okay, so these have as their substrate a different molecule. Okay, these are going to phosphorylate the 3rd carbon of the inositol ring within phosphatidylinositol 4-phosphate molecules, so PI4P molecules. Okay, like so. So once again, we'll colour this in. Here we have the 2 long-chain carboxylic acids. Here in green is our glycerol molecule. Okay, here in blue is our inositol ring, and then we've now got 2 phosphate groups coming off here, the one that's within the phosphatidic acid molecule, and then the one that comes off the 4th carbon of the inositol ring. So remember, this is PI4P here. Okay, and we're now going to phosphorylate the 3rd carbon of the PI4P molecule, okay, to produce another phosphoinositide where we have 2 phosphate groups coming off the inositol ring, but this time this is not phosphatidylinositol 4,5-bisphosphate, but instead phosphatidylinositol 3,4-bisphosphate, and this is a different molecule to phosphatidylinositol 4,5-bisphosphate. Okay, so once again, here's the inositol ring in blue, here are the long-chain carboxylic acids in orange, and here is the glycerol molecule in green. Okay, so this then now, this is phosphatidylinositol, so PI, and now we've got phosphate groups coming off the 3rd and the 4th carbons of the inositol ring, and then we've got 2 of them, so PI34P2. Now you cannot abbreviate PI34P2 down to PIP2, okay? If you abbreviate this down to PIP2, people will think you are talking about PI45P2, okay? So that's the only one that can be abbreviated to that, not this one. Okay, so this is a different molecule to this, and I hope you understand why now that I've explained the optical isomer of inositol that we are using here. Okay, right. Now finally, the type 3 phosphoinositide 3-kinase enzymes. Okay, so these are going to work on a substrate of phosphatidylinositol itself. Okay. So let's draw phosphatidylinositol, and they are going to add a phosphate group onto the alcohol group that comes off the 3rd carbon of the inositol ring to create PI3P. Okay, so let's colour this in. So this is our substrate here. This is the inositol ring here in blue. Okay, here are the long-chain carboxylic acids in orange. Here is the glycerol molecule in green. And here is the phosphate group. Okay, so this is phosphatidylinositol, which we'll just abbreviate to PI. And now type 3 phosphoinositide 3-kinase enzymes are going to phosphorylate the alcohol group that comes off the 3rd carbon of the inositol ring in these phosphatidylinositol molecules. And therefore, they are going to create a molecule that looks like this. Okay, so here are the long-chain carboxylic acids in green here. In orange here. Here in green is the glycerol molecule. Now we have these 2 phosphate groups in purple, and then here in blue is the inositol ring. Okay, And this structure is phosphatidylinositol, and now it's free phosphate. Okay, right, so those are the 3 different types of phosphoinositide 3-kinases, and as I say, they differ not in what they do, but what they do it on, basically. They differ in their substrate, and therefore they also differ in what they actually produce as the end product. Okay, right, so in this video we are going to focus on the type 1 phosphoinositide 3-kinases. Okay, so in the next video what we'll start talking about is the structure of the type 1 phosphoinositide 3-kinases, and we'll then talk about the different types of type 1 phosphoinositide 3-kinases, and then we'll move on to their activation by activated receptor tyrosine kinases.